This is Keith and Brian for homework 1. So for the NFET, in order to find UT, starting with the source sweep, looking above the threshold, the IV curve is exponential, so the log plot of the current against the voltage is linear in this region. So UT can be taken directly as the gradient of this region. For finding kappa on the gate sweep below the threshold, again the IV curve is exponential, so on the log plot this is a linear region with a factor of k as the gradient, the factor of kappa as the gradient. For finding the threshold voltage, this is the voltage where the IV curve changes from being exponential to being quadratic. So we took a quadratic polynomial fit of the IV curve above the threshold, and then a linear polynomial fit of the logarithm of the current against the voltage in the sub-threshold region, and then equated the two, found the intersection of these two polynomial fits to find the threshold voltage.
For a MOSFET operating in saturation mode, sigma is equal to the gradient of IDS with respect to the drain voltage. This is caused by the early effect because even though VDS is greater than 100 millivolts and the transistor is saturated, IDS continues to increase by a linear factor of sigma. So all we did here was polyfit the line and extract the value of sigma. For calculating I naught, we just took the value of IDS when VGS was equal to 0 in the gate voltage sweep. In the picture we have here, it's showing a log, but we didn't take the log value, we just took the regular Y value. For the experimental data that we did using the FPAA, our local results are shown by the green line, and the remote results, which Professor Dora gave us, are shown by the red line. The blue line is basically just a mirror. It's just the input voltage plotted by the input voltage just to give a reference. So the green line shows a much better A to C to DAC conversion, and the red line really does not have that nice one-to-one slope. It has a 0.5 slope. I'm not sure for the reason for this, but the green line does show correct results because the input voltage 0.2, 0.4, 0.61 is matched by the output voltage 0.2, 0.4, 0.61. So the analog to digital and then digital to analog works properly for a remote device, but for a local device, but the remote device does not.